Hello everyone, we are going to do systems of linear equations, their determinants today. Okay, so we're going to do 2 by 2 and we're going to do 3 by 3 matrices. Those are the two things we're going to do. And first we're going to learn how to find the determinant and then we'll learn how to use it. So determinants of 2 by 2 matrices. Alright, so it's generally represented with a capital D. And if we had a matrix and the letter or the numbers went like this, A, B, and then C, D, in a regular matrix, those would be numbers. What you do when you do the determinant is you're going to like crisscross. So you're going to multiply this number by this number. So A times D. And then you're going to subtract this way, B times C. Alright, so for example, let's look at number 8. Number 8 has 8 and 4, and then negative 3 and 2 for the second column. Okay, so if we were told to find the determinant of this matrix, we would go this way first and do 8 times 2 minus, and then go this way. So negative 3 times 4. Just got to be careful with those negatives there. So 8 times 2 is 16, minus the negative will be plus, and that's 12. 16 plus 12 is 28. So that's the determinant of that 2 by 2 matrix. Alright, when you're doing a 3 by 3, it's definitely harder, just more involved. The concept's still the same. And there is a way to do these on calculators, but of course I'll show you both ways. Alright, so if we had a 3 by 3 and the numbers across are A, B, C, then we have D, E, F, G, H, and I. And we have these straight ends to the determinant instead of like the brackets. Okay, the determinant, or one way of doing it, is to write the matrix. You're going to have to set this up a little different. You can't just, like if you go this way, you have to go that way 3 times. And we can't do it like it is right now. So I'm going to write what we have. We have A, B, and C, D, E, and F, G, H, and I. And then I'll finish the determinant, and what I'll do is I'll write these 2 rows, this row and this row, on the outside of this determinant. So A, D, G is the first column. Second column is B, E, H. Alright, so when you do the determinant of a 3 by 3 matrix, you're gonna, same, like I said, same concept. So start this way first. So you're gonna multiply A, E, and I. Plus, then do the next one. B, F, and G. Being multiplied. Plus, and then the last one we have C, D, H. Okay, same way we started the other one, except it was less complicated. Alright, then minus going the other way. So starting with C, E, G. Oops, dang it. C, E, G. That's a C. Minus A, F, H. minus BDI. Oops. And you would do all the math behind it and find the value of your 3 by 3 matrix. All right, so looking at number 12. Number 12, we're supposed to find the determinant of a matrix that starts 1, 6, 8, and then 3, 1, 2 is the next column, and the last column is -2, -5, and 3. All right, so we're supposed to find the determinant of that. So what we're going to do is take those first 2 rows and put them on the outside. So 1, 6, 8 is going to come out here. And then 3, 1, 2 will be right after it. So then to evaluate this matrix, we're going to do the multiplication on the diagonals, just like we did in the one right above it. So start with 1 times 1 times 3. Plus, then we have 3, -5, and 8. Plus, then -2, 6, and 2. Now we go minus for the diagonals going the other way. So the first one is a -2, a 1, and an 8. Minus. The next one is 1, -5, and 2. I'm going to run out of room. And then minus the last group, which is 3, 6, 3. Oops. Okay, so then you just do the multiplication and you do the addition or subtraction. All right, so 1 times 1 times 3, that's 3. And then this will be -15 times 8, that's -120. Plus a negative, again this will turn negative. 4 times 6 is 24. Minus a negative again will become plus. 2 times 8 is 16. Minus a negative can become plus, and that's 10. And that'll stay minus, and 3 times 6 is 18. 18 times 3 is 54. And then you just throw all that into your calculator, and you see that the answer is -168. Or 169. And that's the answer. Alright, so that is finding the determinant themselves. Alright, this will lead us into the application. This is going to be Kramer's rule. This is another way of solving a system of equations. Oops. All right, and this is for solving a system of equations. Oh, hang on, before I go on. I just realized I did want to show you that you could do that in your calculator. So if we take that last one, and we put the original matrix into our calculator. So second matrix, we're going to edit. This is a 3 by 3 matrix. I have 1, 3, negative 2, 6, 1, negative 5, and 8, 2, 3. Okay, go back to our home screen, second quit to home. Then I want to find the determinant of it. If I go second matrix, math, it's actually number 1, DET, that's determinant. So determinant, and then I go back to the matrix menu of number 1, the one I just entered, matrix A, and there's the answer, negative 169. So then we know we did it right. Okay, so that's for those of you who do have the graphing calculator. All right, so back to Cramer's rule. If you have a system of equations, okay, we'll say we have one equation, which is something times x plus something times y equals s. And then we have something like c times x plus something like d times y, and it equals t. But that's our system of equations, just a generic system. You're going to have an x determinant, a y determinant, and then just the regular determinant. The x determinant, d sub x, now this is kind of weird. This s and t actually come and take the place of your x's. So instead of putting a and c, like your coefficient for x, you put s and t. And then for y, since this is the x determinant, it'll stay b and d. Okay, that's your d sub x. D sub y is similar, except our x's will stay a and c, and our y's will get replaced with the s and t. And then finally, there's just the regular determinant, d, which is everything but the answers. So a, c, b, and d. Okay, now what you do with those, because we're solving for x and y, so what you do is x is your d sub x determinant divided by your d determinant. And the y is your d sub y divided by your d determinant. Make sure you know this process. And this is what gives you your answer. All right, so let's look at number 16. Okay, number 16, you have a 2 by 2 system of equations. We have x plus 2y equals 5. And x minus y equals 3. All right, so our d sub x determinant will be, we don't write the x coefficients, we write 5 and 3. And then for y, we do 2 and negative 1. Then our d sub x, or sorry, that was d sub x. Our d sub y would be our x coefficients, which are 1 and 1. And then don't write the y coefficients, instead write the 5 and 3. And then the just plain old d determinant, we don't use the answers at all, just the coefficients of the x's, which is 1 and 1, and the coefficient of the y's, which is 2 and negative 1. Alright, so I'm going to evaluate each of these to find my d sub x, d sub y, and d. For d sub x, going this way first, we have 5 times negative 1, which is negative 5, minus 2 times 3, which is 6. So d sub x equals negative 11. 2 by 2s are way easier to do than the 3 by 3s. D sub y, we have 1 times 3, which is 3, minus 5 times 1, which is 5. So d sub y is negative 2. And then finally, 1 times negative 1, that's negative 1, minus 2 times 1, which is 2. Negative 1 and negative 2 is negative 3. Alright, so now to find our actual x and y. X, remember, is d sub x over d. So x would be our d sub x, which is negative 11, over our d, which is negative 3. So x is negative 11, or sorry, it would become positive. So x is 11/3. Right, and then for y is your d sub y over d. So d sub y is negative 2. D is negative 3. Negative 2 over negative 3, it'll stay a fraction, but it is positive. So y equals 2/3. So our final answer would be the point with 11/3 for the x and 2/3 for the y. And that's using Cramer's rule. And you could use your calculator. Honestly, I think this one's probably easier to do without your calculator, because it's not that bad to do by hand. All right, let's look at number 34. Now 34 is a 3 by 3. I'm going to use Cramer's rule to solve it, but I'm actually going to use my calculator for this one. Okay, so we have 3 equations. 3 equations, 3 unknowns. X minus y plus z equals negative 4. And then 2x minus 3y plus 4z equals negative 15. And 5x plus y minus 2z equals 12. Alright, so d sub x. This we would put the answers in for x. So negative 4, negative 15, and 12. And then our y's would be negative 1, negative 3, and 1. And our z's would be 1, 4, and negative 2. Okay, so you could do this one by hand. I'm going to just use the calculator to do it. So I go into matrix. I'm going to replace A. So, oops, I didn't mean to do that. So second matrix, and actually go to edit. It's already a 3 by 3. So put our new numbers in it. And then I'm going to find the determinant. Actually, you know what? I can do second enter. It brings up this last thing, but now A is different, so it'll give me a different answer. So the determinant for x is actually negative 5. All right, now we do y. Okay, so now the x's are the coefficients of the x's. The y's would be the answers. Oh, dang, that's a 15. 12. And then our z's will be our z's. The coefficients of the z's. Okay, so I'm going to make this matrix B. So edit, but I'm going to edit, make it B. Oops, not 3 by 3 of 33. That would take a while. Okay, so 1, -4, 1, 2, -15, 4, 5, 12, and -2. Okay, go to the home screen. The determinant of B, and I get -15. Right, and then last we need to do the one for Z. So X and Y would be what our coefficients for X and Y are. And then Z becomes the answers. Alright, so go under matrix. I'm going to edit, make this one C, put in my numbers. Go back home, put the determinant in. This time it's C, so I get 10. Oh, I'm not done yet. Dang it, I should have moved this one over. Oh well. We also need to find D. And that's our matrix without the answers in there. So putting in the X's, 1, 2, and 5. Putting in the Y's, -1, -3, and 1. And putting in the Z's, 1, 4, and -2. Alright, so one more time, this will be matrix D. Honestly, it's probably easier to reduce row echelon form for 3 by 3, even when you're using your calculator. This is definitely more efficient for 2 by 2s. Oops, I have to edit first. Putting in a 3 by 3. Still good to know your options. And be prepared to answer questions on Cramer's rule too. It could just be about the process. Actually, I think I can do second enter. That didn't work. Alright, so the determinant of matrix D then is -5. Okay, so we found all the determinants we need. Now we just need to find X, Y, and Z. So X would be our determinant for X, which gives us -5. And then over our D, which is -5, so we get 1. Y is our determinant for Y, which is -15, over D, which is -5, so you get 3. And then Z, we have our determinant for Z, which is 10, and divide that 10 by the -5, and you get -2. So there's your answer. That's what's left with 1, 3, and -2. Let me put it all together. So probably not the most efficient way to do it, especially doing it by hand. That would take forever. But I think Cramer's rule is useful with the 2 by 2s. All right, I do want to look at one more column in section 11.3, and that's number 44. It's kind of a little different. All right, for number 44, you're given that the determinant with, let me get rid of this. The determinant with X, Y, and Z across the top, like the letters X, Y, and Z. And then U, V, and W in the next row, in 1, 2, and 3. And the next row equals 4. And they want us to evaluate, oops, this matrix, or this determinant, with X, Y, and Z in the top, U, V, and W in the next row, and 2, 4, and 6 in the last row. So what it is, if you compare the two, the last row is the only one that multiplied by 2. Remember, the straight lines do mean that it's a determinant. So if just having one row with 2 is the same as having the entire determinant without the 2 being multiplied by 2. So like take the original like this is equal to this, because the 2 can be on that is 2 times the entire determinant if just one row is being multiplied by 2. So this answer would be 2 times 4, which is 8. So the rule is if any row or column in a determinant is multiplied by a non-zero number, the value of the determinant is also multiplied by that number. So if any row or column in a determinant is multiplied by a non-zero number, the value of the determinant is multiplied by that number also. All right, that is 11.3. Hope you're doing okay with these matrices. I hope to talk to you guys soon. If you have any problems, feel free to email me. If I don't answer you, remember, just email me again. So I'm not intentionally not emailing back. So thank you. Have a great night or day.